Hey, it's Dr. J. We're going to do the last section of Chapter 7 today, 7.4, Trigonometric Equations. So I'm just going to put something at the beginning that will just apply to most of the lecture today, unless specified otherwise. So in other words, unless I say so, all solutions are on the interval 0 to 2 pi. In other words, one rotation counterclockwise from 0 all the way to 2 pi. Not including 2 pi, for obvious reasons, 0 and 2 pi are the same thing. So if you have a choice between the two solutions, you're always going to choose 0 and not the 2 pi solution. Okay. So we're going around the circle counterclockwise, one rotation. Let's start off with some just elementary exercises to get the ball rolling. Let's solve a couple basic ones like sine theta plus 1 equals 0, cosine theta plus 1 equals 0, tan theta plus 1 equals 0. So the three principal trig functions, sine, cosine, and tangent. So basically, your theta is acting like your x, and you're going to solve. I'll show you sort of the mechanical way to do it, which is to move the 1 to the other side. And you get your sine theta is equal to -1. Or in this case, you're going to get cosine theta is equal to -1. Or in this case, you're going to get tangent theta is equal to -1. Okay. Now, if you had no prior knowledge of trig, well, I don't know why you'd be in this course if that were the case, but I mean, if you had no idea what you're doing and you didn't know anything about the unit circle, you could just put this into your calculator, and you know that's okay if you really have to do that. The problem is you're not going to get a nice value. You'll just get some decimal. Let me show you what it would look like. So for sine, you would do sine inverse of -1 if necessary. And you could do that if you really wanted to. You hit -1 on your calculator, and then I think it's a second function. And then right above the sine button is your sine inverse button. And you're going to get theta is -90. Yeah, if it's in degree mode. If you've got your calculator in radian mode, you're going to get -1.57. That would be radian mode. The problem is neither one of these are in the proper interval. It's not in this interval. So you would then have to do extra work to take these calculator answers that you got and translate them into a radian measure from 0 to 2 pi. Technically, -1.57 is a radian measure. I'm not sure if you recognize it. It's -pi/2. It's not very easy to see, but I'll ask you, can you see -pi/2? I'll just ask a question. If you're not sure, try it on your calculator. Hit pi divided by 2, and what do you know? You get -1.57 if you do pi divided by 2. Not very many people, including myself, recognize a decimal as a traditional radian measure. You just might not recognize it. It's not something that you've been trained to identify. So I would avoid this if possible. All right, so only use the calculator and the inverse button on your calculator if it's absolutely necessary and you have no other way of solving the equation. I would say 90% of the problems that I put on the homework and the test as well involve special angles at this point. All right, we haven't really gotten into the deep end yet. So the best way to do it is to draw a unit circle. You got your 0, pi over 2, pi, 3 pi over 2. And then remember, every point xy is equal to cosine theta, sine theta. It's a much easier way of thinking about it. So what do you have here? You've got the point here would be 0, negative 1. This point here would be negative 1, 0. This point here would be 0, positive 1. And then the 0 is the same as 1, comma 0. So you have all your x, y values are equal to cosine theta and sine theta. And now you can just kind of go around the circle and read them off. So you just read this. What angle has a sine of negative 1? And there it is. Sine is equal to negative 1. Right there. So your answer is much easier if you know the unit circle. You can just say theta is 3 pi over 2. And now you have that it's actually in the interval from 0 to 2 pi. All right, remember we're going around counterclockwise. So you have to go all the way around to here, and that's 3 pi over 2. And now you can just read off all of these answers. Well, at least sine and cosine you can read off. Tangent's a little bit different. So cosine is negative 1 right here. Yeah, cosine is the x value of that coordinate. So you just read it off. Theta is pi. Yeah, much easier than trying to use your calculator, although you probably would recognize that one. Right? If you do that one on your calculator, just for fun, you get negative 1, and then you hit cosine inverse, and what do you know? 3.14159. I think everybody would recognize that one. Pi is one of the easily recognizable numbers. Okay. Now, tangent is a little bit different. Tangent, you don't get a exact sine or cosine value like you do here. It's the ratio of sine to cosine. Yeah. So to find tangent theta equal negative 1, you have to think, what angle or angles have a tangent of negative 1? So you draw your unit circle. This time you're talking about negative 1 is the slope. So you have two solutions. Sorry, my picture is really bad. It didn't go through the origin. You have two solutions. I'm making it worse. You have one solution in quadrant 2, and you have another solution in quadrant 4. Both of these points have a tangent of negative 1. If you're not sure about that, think about the x and y values here. The x value here would be negative root 2 over 2. And the y value would be positive root 2 over 2. Yeah. It's basically 45-degree triangle in quadrant 2. And then down here, your x value would be positive root 2 over 2. And your y value would be negative root 2 over 2. Again, these are cosines and sines. And so sine divided by cosine, right, would be radical 2 over 2 divided by negative radical 2 over 2, which is clearly negative 1. Yeah, you're dividing a number divided by its opposite. Yeah, radical 2 over 2 divided by negative radical 2 over 2. You're going to cancel everything out, and you're going to get negative 1. Okay. And the same thing will happen in this quadrant here. In quadrant 4 down here, you got sine theta over cosine theta is negative radical 2 over 2 on top and radical 2 over 2 on the bottom. And again, everything cancels out, and you just get negative 1. So this one has two solutions. You have theta equals 3 pi over 4. That would be this point here. 3/4 pi, or 7/4 pi. 7 pi over 4. So you have two possible solutions for the tangent to equal negative 1. Now, two possible solutions if we only go around the unit circle one rotation. Obviously, if we allow multiple rotations, or if we allow it to go clockwise, you're going to get more than one solution. So that's why for this particular lesson, I'm going to have all my solutions just be one rotation around the horn. All right, that's the basic idea. Let's do a few more examples. Example 2. Solve two sine theta equals negative 1. Let's do 2 cosine theta equals radical 3. And 2 sine theta equals radical 2. I've intentionally set all these equations up so that there's really only one step before you go to the unit circle. You might as well just do that step mentally. Get that over with on all of these. So you're treating your trigonometric function like your x. That's what you're solving for. And then you're only going to use the inverse trig function if necessary, if you do not recognize the value. I'm really just reminding everybody, maybe it's been 6 months or so since you did all these basic trig functions, but I just want to make sure that you don't leave this course without having a good understanding of the unit circle. So we're going around the unit circle. Let's just solve these one at a time. So what angle, it's the way you read this. Let me put that up there. What angle has a sine of negative 1/2? That's how you read it. Well, you know you have to be in quadrants 3 or 4 because it's negative. Yeah? Sine is negative in these two quadrants. Yeah. So it's negative 1/2. Those are two special triangles. Yeah. There's a couple different ways to do it. In a true unit circle, it looks like this. Yeah, so your y value is negative 1/2. Your x value is negative, your y value is negative 1/2. Your x value is negative root 3 over 2. And then the 1 is called the r, or the radius of the circle. So it's x, y, and r if you're doing a true unit circle. So for here, it's x equals positive radical 3 over 2, and y equals negative 1/2 again. And so you should recognize these angles. These angles are 30 degrees. Yeah, that's the reference angle. So you're going to go 180 plus 30. So that's 210 degrees. That's this one. And then for this one, you're going to go 360. That's a whole circle minus 30, because you're going backwards down 30 degrees. So that would be 330 degrees. Okay. Now, technically, when I say 330 degrees, what do I really mean? I mean starting here and going all the way around to here. That is 330 degrees. Yeah. It's 30 degrees shy or 30 degrees away from a full rotation. If you add these together, you should get 360. Okay. Now, I don't want any answers in degrees in this section. I don't think any of the problems allow degrees. You can think about it in terms of degrees. I often do. When I'm rotating around the circle, I'm thinking 45, 90, 180. You know, you think like that because you're a human being, right? There's 360 days in a year approximately, right? So you've been doing this your whole life. I know it's 365.25, but for mathematical purposes, it's 360. It's one rotation. Okay, so I want you to turn these angles into radians. You probably already know it. This one is 5 pi over 6, or is it 7 pi over 6? 7 pi over 6, good. And then this one is 11 pi over 6. If you don't know how to do that mentally, then I'll show you the recipe one more time. So 210 degrees, you're going to multiply by pi over 180. If you don't know how to do this mentally, you can do it mechanically. Literally solve, cross off the degree symbols. So you get 210 pi over 180. Divide those. 210 is divisible by 30 7 times. 210 divided by 30. And 180 divided by 30 is 6. So 7 pi over 6. Just divide these by 30. Okay. You can do the same thing with 330. So you got 330 degrees times pi over 180. And you're going to cross off the degrees. 330 pi over 180. Those are also divisible by 30. So that's 11 pi over 6. You just divide the top and the bottom by 30. It's not always going to be divisible by 30. Sometimes it's divisible by 10. Sometimes it's divisible by 45. Sometimes it's divisible by 15. Whatever it happens to be divisible by. Okay. I spent a lot of time on part A so that you get the idea. Now that we've got part A, we could probably go through and answer all the rest of them. Let me just stash my answers over here. For part A, the answers are 7 pi over 6, comma, 11 pi over 6. You don't need to put any parentheses, brackets, braces, fancy pants on your answer. Just type the two answers in, separated with a comma. Okay. All right, I made a real mess of this, so I'm going to have to clean it up a little bit. So let's try another one. Hopefully you can just spot them right away. What angle has a cosine of radical 3 over 2? Remember, cosine of theta is positive in quadrant 2 and quadrant 1. So these are the two places where cosine is positive, both of these quadrants. Last time I used a true unit circle. A true unit circle has a radius of 1. but we don't often memorize them that way. When I was your age, I memorized it this way. It's much easier because it looks like 1, 2, 3. Yeah. Just remember, it's not really 1, 2, 3. It's 1, 2, radical 3. 1, 2, radical 3. That's the trigonometric way. Yeah. And now that I just said that, I realized you're probably screaming at your computer right now. Cosine is positive. I was still stuck in sine mode in my brain. So let's switch over to cosine mode. Correction. Quadrants 1 and 4. We're talking about cosine being positive. So our two answers are 60 degrees in quadrant 1. Now you could say negative 60 degrees. Yeah. Negative 60 degrees, but that's not going counterclockwise. If you go counterclockwise, you have to go all the way around the horn. That's negative 300 degrees. So your solutions, you need to turn 60 degrees and not negative, positive 300 degrees, because we're going around counterclockwise. So we have positive 300 degrees and positive 60 degrees. Turn those into radians. You can use the same technique we used over here. 60 degrees times pi over 180. That one's pretty easy because 60 goes into 180 exactly 3 times. So you just get pi over 3, crossing off the degrees. Okay. And then this one over here is 5 pi over 3. That's the same as 300 degrees. So clarification from the beginning, cosine is positive in quadrants 1 and 4. Sine is positive in quadrants 1 and 2. So let's go ahead and go back to quadrants 1 and 2. For this last one, sine is root 2 over 2. Those are 45-degree triangles in quadrants 1 and 2. And again, you could do a true unit circle, or you could do the much simpler version. And we're talking about sine, so all I care about is the y value and the hypotenuse. I don't care about the x value when you're doing sine. So this one would be 45 degrees. So the answer to part C is theta is pi over 4. That's right here, pi over 4. And we already know this one from earlier. 3 pi over 4 because it's in quadrant 2. All right, so here are your answers. 7 pi over 6, 11 pi over 6, pi over 3, 5 pi over 3, and pi over 4, 3 pi over 4. All right, so that's the basic idea of using the unit circle. I would say probably the first 10 problems on the homework are all based on the unit circle, and they're all special angles, 30, 60, 90, 45, one of those. They get a little bit worse or a little bit better, a little bit more interesting. Example 3. Let's go ahead and just solve one equation. Let's solve 2 cosine 3x is equal to 1 on the interval 0 to pi. So now I'm specifying that we're only going to go between 0 and pi. So this means we're only in the upper half of the unit circle. I'm also using 3x as my theta. Here's the way I do these. I actually write theta. Now, you don't have to do this part. This part's optional. But I just find it easier to not really worry about the 3x right now and just worry about theta. So 3x is theta. Yeah. And now when I solve it, it's just like the problem I just did. You know, what angle has a cosine of 1/2? And it has to be between 0 and pi in this case. So 0 and pi, cosine is 1/2. 1/2. This is root 3. Yeah. 1/2. So that would be 60 degrees, pi over 3. So here's my theta right here. Now we're not done yet. Yeah. X has to be between 0 and pi. Not theta, but x. So I know that theta is pi over 3, or where else could it be? Yeah, this is theta. Theta can be much larger than 0 to pi. Yeah. If x can go from 0 to pi, here, let's do a little sandwich. If x is between 0 and pi, then 3x could go all the way to 3 pi. 3 pi is 1.5 rotations. So I've got a couple more possibilities here for theta. I need to continue going around a couple more times. So this is one possibility, but I also could have down here in quadrant 4, so theta could be 5 pi over 3, which is the same as 300 degrees. Okay. Or there's one more. I could go all the way around 360 plus an additional 60 to get 420 degrees. Man, my pens are dying on me. 420 degrees. That would be one rotation plus an additional 60 degrees. So I'm going all the way around, and then another 60 degrees puts me right back here. It's essentially the same triangle as this. It's just been rotated around. So that would be 7 pi over 3. And remember, this is not my answer. This is theta. Now I need to switch back to x. So I've got 3 possibilities for theta. Theta is pi over 3, or 5 pi over 3, or 7 pi over 3. But now I need to switch back to x. All right, and then if you decided not to do the substitute, just to keep it x the whole time, then you already have an x over here. So you got 3x is pi over 3, or 5 pi over 3, or 7 pi over 3. And now you're going to divide everybody by 3. And that's going to give you your x. So your final answer for x, divide all of these by 3, and you're going to get x is pi over 9, or the comma means or 5 pi over 9, or 7 pi over 9. Remember from elementary school, when you divide a fraction by 3, you multiply the denominator. Yeah. I've seen a lot of my students forget their basic math, and they'll accidentally cross off those 3's. Don't do that. Remember basic arithmetic. Dividing by 3 is the same as multiplying the denominator by 3, or multiplying by 1/3. Same thing. It's the little things that get you in the end. Okay. Want to try another one? Sure you do. I'm switching to blue now. So let's solve sine 2x plus 1 equals 2. I don't know why I had to think about that so much. Just decide if we're going to do another special angle or not. All right. And let's do this on the interval 0 to 2 pi. Okay. So remember, x must be on the interval 2 pi. So this means x is between 0 and 2 pi, not including 2 pi. So 2x can go all the way to 4 pi. Just multiply everybody by 2. Or you can call this theta. I like to switch to theta. And then my equation looks like this. Sine theta plus 1 equals 2. Yeah, just switching my 2x into a theta. The good thing about these trig equations is none of them involve any really complicated equational math, because I'm not going to give you a really complicated equation to solve. I'll give you a really simple equation, but you have to know the trigonometry. So what angle has a sine of 1? And it has to be between 0 and 4 pi, which is 2 rotations. Yeah, 2 rotations. So you go around the unit circle 2 times. Remember, sine is the same as the y value. If you think of this as a point, 0, 1, the y value is sine. So on the unit circle, you all recognize that as 90 degrees or pi over 2. That would be in the first rotation. And then as you go around a second time, in the second rotation, it's going to be 2 pi plus pi over 2. In other words, a whole 360 plus an additional 90 degrees. And so that's going to be 5 pi over 2. All right, it's the same angle. It's in the same location. It's just more rotations. Okay. So So that means theta could be pi over 2 or 5 pi over 2. I'm switching back to x. And then I'm going to divide everybody by 2. And that's it. Remember, when you divide by 2, it's the same as multiplying by a half. So your final answer is x is pi over 4 or, comma, 5 pi over 4. I'm not checking my answers mainly because of the clock running. You know, I know I'm under a time limit here. I want to get this done in an hour. But if you want, you could take these numbers, plug them in for x, and verify that they, in fact, come out to be valid solutions of the problem. If I start doing that now, we'll never get past example 3 or 4. So I'll leave it to you to check on your own. Example 5. Three sine squared x minus 7 sine x plus 2 equals 0 on the interval 0 to 2 pi. This is pretty standard, 0 to 2 pi. There's only maybe 1 or 2 exceptions to this where I change the interval a little bit. So make sure you read carefully. You don't get caught in the one exception that's not true. If you see a exponent, it's a clue that you're going to be doing some factoring. Now, you got 2 ways to factor. One way is just to guess. I hope that you're all relatively good at guessing. So you don't have to switch variables or anything like that. You could just say, well, I know that sine times sine is sine squared. And then 3 times 1 is 3. So I hope that's an obvious guess. 3 sine and 1 sine. Notice I don't really put the 1. It's invisible. If you multiply these, you get 3 sine squared. Yeah. Now look at the 2 and guess 2 numbers that multiply to be 2. Maybe 2 and 1. Yeah. Don't worry about the signs yet. Put the signs based on the middle term. Yeah. You want them to multiply to be a positive, but add to be a negative. I know I don't need to be telling you this. You probably remember this from algebra. But I don't know. Maybe it's been 2 years. Maybe it's been 10 years. I don't know how long it's been. So if they're going to add to be a negative, then they have to both be negative, and they're going to multiply to be a positive, so they're both going to be negative. Now again, this is a guess. I wouldn't trust this. I would check by multiplying the 3 and the 2. Yeah, 3 sine and 2, so you get negative 6 sine, and then multiply the inner. Negative 1 times sine is negative 1 sine. And you want to check that the middle term comes out to be negative 7 sine. Check. If you put the 2 and the 1 accidentally in the wrong spot, now would be your chance to fix it. OK, it checks. So now we're going to solve 2 equations. 3 sine x minus 1 equals 0. Or sine x minus 2 equals 0. So we're going to split this into 2 separate equations. They should both be relatively simple. In fact, I'll skip some of the steps because you guys are getting to be experts at solving equations. So this equation resolves to sine x equals 1/3. Yeah, just moving the 1 and dividing the 3. And this one resolves to sine x equals 2. Remember, sine x is never bigger than 1, and it's never smaller than negative 1. So this is impossible. We call this extraneous. Yeah. There is no real solution for sine x equals 2. I don't even think there's an imaginary solution for it. There's just no solution. Sine is never going to be 2. Not in this world. However, this is less than 1. So you do got to keep this in mind. You're never going to have a sine or a cosine. This applies to both sine and cosine. Must be between 1 and negative 1. You probably remember from the oscillating graphs in Math 5. They always bounce between 1 and negative 1. Unfortunately, 1/3 is not a special angle. So we have to resort to using the inverse button on our calculator. All right. Make sure you're in radian mode. Use your calculator in radian mode. Set your calculators to rad mode. All right, so I got 1/3 and then sine inverse, and I'm going to get .3398. I guess we'll go to 4 decimal places. If it's not specified, 4 is a safe bet. All right. Okay. Now, is that the only solution? Remember, we're on the interval 0 to 2 pi. So if you ever think about what a radian is as a decimal, a very easy way to remember it is 1 radian is about 57 degrees. It's just a quick way of remembering, what is 1? So, so that you know where .33 is. So that means .33 is somewhere in here. It's definitely less than 1. Yeah. It's less than 1 radian. So it's definitely less than 57 degrees. But isn't there another one over here that also has a sine of 1/3? This is your second solution. So you do have a second solution. Yeah. It's going to be pi minus your original solution, .3398. So you're just going to do pi minus .3398, and you're going to get, so let's call this one x1, and then we'll call this one x2. So x2 is 2.8018. So there are 2 solutions. I usually put the smaller one first, so .3398 and 2.8018. So those are your 2 solutions. This inequality just reminds the reader that I'm putting the smaller one first and the larger one second. I like to put them in order as they appear in the circle. So once in a while, you're going to need the calculator. And when you use the calculator, remember the calculator only gives you one solution. It's an inverse function. An inverse function is 1-to-1. It means that one input gives you one output. But the unit circle often has more than one solution, so you have to go back to trigonometry and remember to recover the second or sometimes the third solution, whatever the case may be. Let's try another one. How about 2 sine squared x minus cosine x equals 1. And we'll stick with the same interval on the interval 0 to 2 pi. Okay, so example 6, continued. 2 sine squared x minus cosine x equals 1 on the typical interval from 0 to 2 pi. The first thing you want to do is use a Pythagorean identity to get rid of one of the trig functions. I typically go with the one that has a square. It's easier to rewrite it than it is to rewrite the non-squared term. Plus, you've probably memorized this since going back to 7.1. Sine squared is 1 minus cosine squared. And now you have an equation that only involves cosine. And you'll find that it's much easier to solve that than it is the original equation. Anytime you have a trigonometric equation with multiple factors of the same function, you want to factor it. You want to also set it equal to 0. So I'm going to subtract 1 from both sides. You also want to write this in standard polynomial order or descending order. That way you get the leading term is negative 2 cosine squared, and then you have your middle term, and then you have your constant term is plus 1. Now you could just go ahead and factor it now, but even for very experienced expert mathematicians, factoring might be very easy for you. I still would recommend getting rid of the leading negative. Just divide everybody by negative 1. And that should make things a lot easier. You're going to get 2 cosine squared plus cosine, and then minus 1 equals 0. So this is the equation that you're actually going to solve. Classic mathematics, what we call the switcheroo, or the rewrite the question in a simpler form, or simply solve an easier version of the problem that you've been given. So we're actually going to solve 2 cosine squared x plus cosine x minus 1. It should be factorable. If you can't factor it within a couple minutes, then you can use some sort of a substitution method or a quadratic formula or something like that. That should not be necessary. I've created most of the problems so that they are exercises in factoring. But I don't know what's coming down the road. If you get something that you can't factor, then try something else. So I always start with a guess. The obvious guess, 2 cosine times 1 cosine would be 2 cosine squared. And then 1 times 1 would be 1. Then I look at the middle term is positive, and the last term is negative. So I want this term to be positive and this term to be negative. And I'm still going to check if I multiply, I get 2 cosine x, and then I get negative 1 cosine x. I want to verify that that comes out to be positive cosine. It does, yeah. 2 cosine minus 1 cosine is the same as 1 cosine x. Yeah. Of course, there's an invisible 1 right here. Invisible 1 right here. Okay? I don't like to write the invisible one. I don't presume that you will either. So much like the last problem, we're then going to split this up. 2 cosine x minus 1 equals 0, or cosine x plus 1 equals 0, and solve these independently and give me all of the solutions in the intervals 0 to 2 pi. So look at your unit circle. What angle? Now, x is now an angle. So if you prefer, you can use theta or alpha or beta. Sometimes that confuses people. When x becomes your angle, then this is no longer the x-axis. So cosine is 1/2 at 60 degrees. Yeah. I'm going to put it down here, 60 degrees. Pi over 3. Cosine is also 1/2 down here at 300 degrees. 300 degrees, we did this a little while ago. That's 5 pi over 3. If you're not sure about that, then turn it into degrees and then use the formula, multiply by pi over 180, and you will get 5 pi over 3. So these are the two places where cosine is equal to 1/2. Yeah, quadrants 1 and 4. And then where is cosine equal to -1? I kind of wish I would have put this one on this side. That would be over here. So cosine is equal to -1 at 180 degrees, which is pi. So give me all your solutions on this interval. Your solutions are, let's put them in order. x1 should be less than x2, should be less than x3. So x1 is pi over 3. x2 is pi. That one comes next. And x3 is the last one, 5 pi over 3. So here are your three solutions. They should all be in the interval from 0 to 2 pi. And you should put them in order from smallest to largest as you go around the circle. All right. And again, if you really wanted to, you could take all three of these answers if it was necessary, or if you're getting some strange, error messages or something, and you want to make sure these are right, plug them into the original problem, and you'll see that all three of these are valid solutions. So I'll leave that as a DIY, do-it-yourself problem. Okay, we're getting into the thick of it now. Let's try 18 sine t cosine t is equal to -3 cosine t. And I want all the solutions on the interval 0 to 2 pi. We want to set this to 0. I'm going to be lazy and not write the parentheses. That's just extra writing. That's not necessary. I'm going to add the 3 cosine t over to the left-hand side, set it equal to 0, and factor out whatever is possible. Look for the largest common factor that you can find. So that's 3. These are both divisible by 3, and cosine t. Don't forget to put a 1 here when you factor out the 3 cosine to the front. Remember, there's an invisible 1 that gets left behind. Now you're going to split these up, setting them both equal to 0. And you should be able to solve these relatively quickly, at least setting them up quickly. So we get cosine of t is equal to 0, just dividing both sides by 3. This one's a little tougher, but I think you all know how to do it. Just subtract 1, divide by 6. You're going to get negative 1/6. This is not a special angle, so you need to use your calculator. So we're going to get t is sine inverse of negative 1/6. T is sine inverse of negative 1/6. So we got 1/6, negative 1/6. That's negative 0.1666666. And then we do sine inverse of that. Now be careful. You cannot trust your calculator. Just give me 4 decimal places, but this is not in the right interval. So this is not the correct interval. It is the correct angle, but it's negative. And this says you cannot have a negative answer. It has to be greater than 0 and less than 2 pi. So we have to adjust this. You can never trust the button. You can't just press the button on your calculator, get the answer, type it in, and think like you're done with it. It's just not going to happen. All right. You got to draw a unit circle and figure out where is this corresponding angle in the interval 0 to 2 pi. All right. You also need to solve this one as well. Cosine of t equals to 0. Just really quickly, let's go ahead and solve that right now. What angle has a cosine of 0 on the unit circle? Remember, cosine is the x coordinate on the unit circle. So here's your t. T is the angle in radians. Cosine is the x coordinate on the unit circle. So this is 90 degrees, or pi over 2. That is a special angle. So let's go ahead and put that one on save. T equals pi over 2. That one's correct. We'll save that one for later. And now we're going to go back and figure out the corresponding angle for sine. So let's draw a unit circle. This is our angle. It's negative 0.1674. But we want to go around the other way. We want to go around counterclockwise and stop at the same point. So going around counterclockwise, you're going to do 2 pi, which is 1 whole rotation, minus 0.1674. That will put you in the proper interval. So let's see, 2 times pi, it's about 6.28, and then minus 0.1674. And you're going to get t is approximately 6.1158. Okay, now don't quit yet. Don't get too excited. You got one more solution to find. I want all the solutions in one rotation. So you have to come over to this side. Same angle, just mirror image onto the other side. That will also have the same sign. Yeah. And so that would be pi plus 0.1674. So you're going to add pi plus 0.1674. And that will give you your last solution. Pi plus 0.1674. That's 3.3090. When you round, I don't know if you can see that, but it's 3.3089. So I have to round that 89 up to 90. All right. Okay, you kind of got all your solutions all over the board here. I like to see them all in order. So list your solutions in order. T is, what's the smallest one? It would be this one, pi over 2. That's the only one that's going to be exact, pi over 2. The rest of them are going to be approximations, 3.3090 and 6.1158. You could actually turn pi over 2 into a decimal as well if you really wanted to make them all approximations. Pi divided by 2 is about 1.5. 1.5708, 3.3090, and 6.1158. I'm not telling you that you have to do that, but I don't know. It might look weird having one of them be exact and the rest of them be approximate. So, you know, if the question says give me decimals, then just give me decimals for all of them, and there you go. All right, so those are your 3 solutions for T. How about this? What if I say find all solutions? Now, I don't give you a limit. I just say find every solution that you possibly can. Yeah. Let's try one. Let's try one. Sine squared x equals 2 sine x plus 3. Same format as all the rest of the questions. Just find all the solutions. Looks like a polynomial already, doesn't it? That means you're ready to go. Looks like a polynomial. Set it equal to 0. And factor it out. I feel like we've seen this one before. Maybe one very similar to this. Yeah, we've seen this one before. I'm just guessing. Sine x times sine x is sine squared x. All right, 1 and 3 is 3. I don't put the signs yet. I look at the middle term and the last term. Okay, I want the middle term to be negative, the last term to be negative. So I want 3 to be negative and 1 to be positive. And then when I add these, I get a negative 2. This one I'm just going to do mentally. When I add them, I get negative 2. When I multiply, I get negative 3. I know I don't need to tell you that, but you know, we've got unresolved issues sometimes. I'm going to make sure that everybody knows how to do these things. Set these equal to 0 and solve them both, if possible. In this case, sine x is extraneous. Yeah. Remember, sine x has to be less than 1 and greater than negative 1 or equal to. So this is never going to happen. You're never going to have that happen. So you really only get one candidate. Okay. So where is sine x equal to negative 1? That would be 3 pi over 2. That's if you know the unit circle very well. Yeah. If not, if you don't know it very well, then draw a circle and find the y value that's negative 1. Remember, x is the angle. We're using x like theta. X is our angle. So technically, you can't call this the x coordinate anymore. You could call it the alpha coordinate or something like that. Or you can call it the first coordinate. But in this case, it really doesn't matter. Sine x is the second coordinate, which is negative 1. So this is 3 pi over 2, also known as 270 degrees. Okay. Now, so ordinarily, I would just give one answer. I would just say 3 pi over 2. Yeah. But I want to find all solutions. So I could go around and around and around. I could add 2 pi. I could add 4 pi. I could add so I could go around 2 pi as many times as I like. Yeah. So 2 pi would be going around 1 time. 4 pi would be going around twice. And that would always get me back to this same point. So any multiple of 2 pi yeah. So to find all solutions, we can add any multiple of 2 pi. And I should be very clear, I mean an integer multiple. Yeah. So an integer, if k is positive, then you're going to go around counterclockwise. That's like in my picture here. I'm going around counterclockwise. If k is negative, you're going to go around clockwise. So that would be going this way. So you're starting down here at 3 pi over 2, and then you can go minus 2 pi. Again, you're going clockwise. Clockwise is negative. Counterclockwise is positive. And I know that's weird. So technically the clock that you read is negative radians. It's going around in negative radians. So you could do 3 pi over 2 minus 4 pi, 3 pi over 2 minus 6 pi, etc., etc. So we can take this solution and we can write all solutions. X is equal to 3 pi over 2 plus k times 2 pi, or we often write 2 pi k, or some people write 2k pi. Yeah, these are all the same thing. Tomato, tomato, tomate. It doesn't really matter how you say it. And then you have to say where k is an integer. Yeah. So k is an integer. K is going to range from 1, 2, 3, 4, 5, or -1, -2, -3, -4, -5. And so this gives you all possible solutions in every rotation that you can think of, even the ones you can't think of. All right, example 9. My black pens are officially dead. I'm using blue, purple, and red for the rest of this lesson. All right, how about this one? Example 9, find all solutions. Eight sine 2 alpha minus 9 sine alpha is equal to 0. Now, I should mention, when I say find all solutions, first find the solution in 0 to 2 pi. So you're always going to do that. You're always going to find the solution in 0 to 2 pi. And then, if necessary, you can expand and give me a multiple of solutions or an infinite number of solutions as you go around the unit circle. This is clearly a double angle formula, which we just learned. So that'll be 2 sine alpha cosine alpha. So 16 sine alpha cosine alpha minus 9 sine alpha. Unfortunately, 16 and 9 have no common factors, so the only thing that I can do is remove a sine. Okay. Split these up. Sine alpha is 0. And 16 cosine alpha minus 9 is 0. Or in other words, cosine is 9/16. Just moving the 9 and dividing by 16. You all know how to do that, right? Now make sure this is actually less than 1. If this is bigger than 1, or if it's smaller than -1, throw it out. It's extraneous. Well, we don't get to throw it out, do we? 9/16 is good. It's not less than 1. All right. Oh my goodness, I just realized I made a mistake. Well, not on this problem, so let's keep going. Sine of alpha is equal to 0. That means alpha is equal to 0. Sine of 0 is equal to 0. Yeah, on the unit circle. Now this is the point 1, 0. So sine of 0 is equal to 0. So we get one of our answers for free. Yeah, alpha is equal to 0. And we get our other solution from cosine of alpha equals 9/16. Unfortunately, that's not special. What do you mean I'm not special? Well, you're not special. Sorry. Everybody's special. So cosine of alpha is 9/16. I need to do the inverse of this, the inverse function. So if cosine of alpha is 9/16, then alpha is cosine inverse of 9/16. Again, in radian mode, 9/16 cosine inverse. Alpha is 0.9734. If you really want to know what that is, you can convert it into degrees. It's about 56, 55 degrees, something like that. If you just like to intuitively know where that is. When you see a decimal, you might, I don't know, what does 0.9734 mean? Well, you just multiply it by 180 and divide it by pi, and you'll get about 56 degrees. Right. Now, that's in quadrant 1. Yeah. There's another place where cosine would also be 9/16. Yeah. So right here, you can think of a triangle like this, 16 and 9. Maybe it would probably look more like this. So the hypotenuse is 16 and the adjacent side is 9. Well, you have another triangle down here. It's like a mirror image of this triangle, and that would be 2 pi minus 0.9734. That would give you this angle in quadrant 4. So let's go 2 pi minus that. So that would be alpha is 5.3098. That would be the one in quadrant 4. This is the angle in quadrant 1. Okay, and then this was my free answer right here at x equals, or alpha equals 0. You get sine alpha is also equal to 0. So before I find all of the solutions, first let's list the solutions in the interval 0 to 2 pi. That would be alpha 1 is 0. Alpha 2 is in quadrant 1. That would be 0.9734. And then alpha 3 would be the quadrant 4, 5.3098. All right, so that would be your sort of primitive solutions or elementary solutions. And now we're going to add multiples of 2 pi to these. So to find all solutions, it would be 0 plus 2k pi, 0.9734 plus 2k pi. So every multiple of 2 pi puts you back in the same place. Sorry, let me put this one underneath. 9734 plus 2k pi. Or you could say 2 pi k, or there's lots of ways to say it. And then there's 3 ways to say it. 5.3098 plus 2k pi, where all of these, where k is an element of the integers. The fancy way to write that is KEZ, where K epsilon looks like a lowercase e. It's a Greek lowercase e. K epsilon z. Z is the universal symbol for the integers. Okay, hopefully that'll do it for 7.4. If you have any questions, you could obviously ask me online tomorrow, or you could email me. If there's any major concerns, maybe I'll tie up some loose ends if necessary. But we are now done with Chapter 7, so take care of each other, and we'll see you tomorrow.